All right, what about this series? So we want to know, is this one convergent or not? Well, this one would be comparable to our series of uh, um, 1 over n to the fifth, which we know this one is convergent by p series, because our p here of 5 is definitely bigger than 1. Well, that would work then if our uh, series here is smaller than the one over here, because a smaller one we know will converge. So is this one smaller here? That's the question. So is that smaller? Well, if we put some positive number in for n, this part of it should be the same as over there. But if we subtract something from the denominator, that's going to make that denominator smaller than the one on the right, which means that one's actually bigger than the one over here. So how can we determine then if it's convergent or divergent? Because our comparison test won't work in this case. It still could be convergent, but it also could be divergent. So what are we going to do? Well, direct comparison fails, so we need to see if there is another way that we can test this one. And there is. We're going to use something called the limit comparison test. So if you can't do a simple comparison, then try this one, limit comparison. So what we're going to do is we are going to take the limit as n goes to infinity of the two series a and b, and if that limit equals c, where c is a finite number that is bigger than 0, then either both series converge or both series diverge, looking at the one that we're comparing it to. However, if the limit comes out to be 0 or infinity, then this limit comparison test fails, and we're going to have to find a new test to use on that one. So when you're doing limit comparison, you want to see, does it come out to be a positive finite number? So let's go back to that one we are looking at. We can still use our comparison here to 1 over n to the 5th power. So what we're going to do now is do the limit as n goes to infinity of the one we're looking at over that one we're comparing to, and see what this comes out to be. So to simplify this limit, let's multiply both numerator and denominator by n to the 5th power. So that in the denominator is going to cancel out these. So now we have this limit. And this limit we know as we go to infinity here is going to end up being 1, because these two are going to win out, and the limit of that as you go to infinity is just going to be 1. That's a positive finite number. So our series here is going to do whatever this series does, and since 1 over n to the 5th is convergent by p series, then by limit comparison, this one is convergent too. So our series we're looking at is convergent by limit comparison test to a convergent p series.